Hello, I'd like to give a walkaround through the BD Rowa StorageSystemSimulator, which you can use to test your implementation of the WWKS2 interface protocol to control Rowa Vmax robots, and give an idea how to work with this system. The Storage System Simulator is part of the WWKS2 SDK, and you should be familiar with this SDK and especially the interface specification to work with this tool. So within the tool, you can first set up the connection parameters, define on which port the simulator will listen for incoming connections, can define the subscriber ID that the simulator will use in all the requests. The default is 999, which is the same that Rowa Mosaic will usually use. Can define how long to wait for a handshake timeout. So you have to send an hello request immediately after the socket is set up. The default timeout of Rowa Mosaic is 6 seconds, so I set this up here. And you can configure if the simulator itself shall send keep alive messages or not. Usually this is your task as well. So I just press listen here. Now the storage simulator is waiting for incoming connections. Usually then you should use your system to connect to the simulator to test. Here in this case I use the IT system simulator so that I have a simulator on both sides. Now system is connected and the storage system simulator shows here that there is a new endpoint. You can have multiple connections in parallel to the simulator, and it shows here as well that the handshake of the hello request has been successful. And the same is something you can check on the log tab here as well, where you can see that the hello request and hello response has been successful. The other hello request and hello response here are from a previous test I did before I started the video recording. So now I will go through these tabs here and explain a little bit what they are good for. The first one, the system status tab, is there to test the status request and response dialog. First, you can just set here what's the default answer if you send a status request without details, and then can tell the simulator will either say, okay, I'm ready or I'm not ready. If you ask for details, then the status response will list the status of several components of the Vmax installation, and you can configure here which of these components should be delivered. For example, there is a storage system, and if you have a multiple Vmax installation with a second storage system, there could be two storage systems, and as well maybe a box system for automatic tote filling. And you can state here what are the elements. And if I now query the status, this information is reported to your system. On the stock input tab, you can test input and emulate inputs. The input into a Vmax always starts with a scan of a barcode at the Vmax, which is then forwarded to you in the input request. You can define the scan code here. You may add a delivery number, which the user has been added before, and can add batch numbers, expiry date, and external IDs if required. If no expiration date is set, then we use a default expiration date, which is today plus 6 months. As well, you can set the overall parameters of the input request as a picking indicator, or is it a delivery input or not. And to simulate the scanning of the pack, just press the scan pack button, and then the input, which is here in the IT system, has been arrived and has automatically, the IT system simulator has automatically sent a response, which you see here with all the important fields. The most important one is that the handling of the input has been allowed. If you want to simulate as well, if a user has really put the pack to the gate of the Vmax so that it's really be inputted, you can switch off this input message auto reply here and then press scan pack again and then decide if the pack is really loaded or not loaded. In this case, I press don't load, and then the dialog has been used, but the input hasn't been completed. Again, you may use the log tab to check the message flow here. And for example, here in the final input message, you see handling input has been aborted. The additional lines here on the stock input are used for future use in case we are able to input multiple packs in parallel. This is not relevant with the Vmax 160. The next two tabs are the master data and the stock delivery tabs, which I use for the article master set request dialog and the stock delivery set request dialog. Both of them are used in very rare cases because they are not fully usable unless you have barcodes on the packs which match your items IDs. This is why I will not talk about them more. The preferred way to input items into the Vmax is to use this input dialog, and this is the one that you simulate here on the stock input tab. More relevant is the inventory checking tab, where you can see what is the current stock in the simulator. Within the simulator, here you see the packs which are currently in stock, and you see the one which we have been inputted before. You see the code I have entered in this input request and the number of packs which are currently here, of course just one. But for example, if I now add another pack, I scan it here, it has been automatically accepted and switch back, then you see the pack count has been increased. And here in the details, you see the details which you have reported back in the input response, which have been stored by the Vmax for these packs. If you want to simulate the behavior of the Prolog OCR, which reports the real expiration date after the input dialog has been finished, you can use this button here, send stock info message to simulate this. Looking into the log, you now here see the stock info message which is sent out in case the expiration date has changed. These buttons here are used to simulate the output of a pack at the Vmax screen. So if not your system has requested the output, but the user is doing this himself at the screen of the Vmax. So if I press here, output pack, it takes a moment and the output, the pack is outputted from the system. Again, here in the log file, you see the output message with the ID 1, which indicates this is an output from the machine and not related to one of your orders. Same is possible to delete a pack here just from this block because you don't want to have it in the simulator, but in this case it will not send an output message. There is an option to load stock into the simulator with a specific file which has to follow a specific format, and you can use this button here, load stock, to do so. So when pressing the button, you're quite where to find the CSV file. There's a specific format which this file has to follow. There's a documentation available how this file has to look like. I just open it here, and you see here now that the information is loaded into the system. There are some limitations with these features. For example, it's not possible to load batch numbers and external IDs into the system. There's no way to define the different pack sizes, and it's not possible to set the max sub item quantity, but for example it is possible to define packs which are broken, which have a sub item quantity set. If you want to clear the stock again, you can just press clear stock and then everything is gone. Now I want to have something, so I just load the stock again. So finally, we have the stock output tab, where you can configure the way how the simulator reacts to incoming output requests from your system. First one is you can say that it should be automatically replied in all cases. In case you want to simulate a box system, you can tell the system to generate a box number if this is required by ticking this tab. And even most important, you can just define how the answer behavior is. For example, the simulator can always say, okay, what you have been requested has been outputted. And in this case, it does not change the stock which is in the simulator. Same applies to always incomplete. In this case, we will just partly fulfill your request and state, okay, has been incomplete. Or we can check if we have the requested items in the stock, so the items which are listed here. And then you can decide as well if we have the items in stock and output them, if we shall update the stock of the simulator or if we should keep the stock. So the most realistic way for simulation is the one according to stock, but of course then the items are gone from this stock which are in the simulator, and you have to simulate another input to bring them into the simulated stock again. I can just show how to work. Just going to the output request in the IT system simulator and create an output request for this one article, which is here in the stock. Sorry, I have to because I updated the stock in the simulator, I have to do the same thing here. I have to reload the stock. So now the IT system simulator is aware of the current stock in the simulator, and now I can choose the right items here. For example, I want to output a pack of this article with the item ID 1111. I want to have 2 packs of that. Just press OK and send it to the Vmax. And now I see here the incoming request, and the one which was listed here before was the one which I pressed in the simulator to simulate an output from the Vmax. And if I now look at the details, now it has been completed. I see the request. It has been article 1111, 2 packs requested and have been fulfilled, and 2 items have been dispensed. And if I now check the inventory, before I had a pack count of 6, now just 4 are left. And again, in the log section, I see the output request that the IT system simulator has sent, the response created by the storage system simulator, and the message which states what really has been outputted and which packs have been used. So this is the quick walkthrough. Maybe just forgot to mention 2 things. Here on the left side of the simulator, you can define tenants and stock locations, which is a very special use case. So if you need them, you can just tell here the system which are defined in the Vmax. And just a big warning with these 2 buttons below here, simulator state, please don't use them because it will cause the simulator to crash. I can show you what happens. Save, there is a crash. So it does not really crash here, it stays continue. But if I now leave the system and try to restart it again, I have a big issue because it will not start. But what you can do to make the system work again is here in this directory where the storage system simulator is located, there are now 5 XML files which haven't been there before. And these have been created by pressing this button, and they make the system not to start again. If you delete these ones now, you're able to start the simulator again. And now it's operation again, but please just don't use them. They're currently not working as intended. So this is the walkthrough. Thank you very much.